Having created an optimized structure, it's appropriate to go up and explore properties of that optimized structure. Immediately after doing computations, the dipole moment is available. If we look at that, this shows the dipole moment oriented as a positive end and negative end, and that's the direction. The dipole moment is 1.65 dBs on the status line here. If we use the selection cursor, we can go up and select a bond. This double bond is now 1.33 angstroms long. Alternatively, we can select an angle. That angle is 122 degrees. So we can explore the structure of this molecule, look at it, and explore the angles, torsions, etc. If you want to see the orbitals, we go up and we ask to see the orbitals. This is the orbital energy diagram with the energies and the symmetries. We can zoom in on these orbitals, put some labels on here if you like. If you want, this is the HOMO orbital. If we want to actually look at it, we can just select it and then say OK. This will plot that orbital. If we want to vary the display, we can go up to isosurface menu item, and we can plot a different value for the orbital contour, or we can choose a different kind of orbital. If we want to grow, this is a Garreau. If we want a Jorgensen-Salem plot, we can get that. Alternatively, if we want these orbitals to be a little finer grid, we can go up and ask to see a finer grid like medium. This will draw it somewhat finer. This diagram of the orbitals. Go back to Garreau shaded and take a look at those orbitals like that. If we want to see the orbital, instead of the orbitals, we want to see the electron density, for example, we can go and ask to see it. Just click on electron density and the electron density for that quantum mechanical calculation. If we want to display this structure in other ways, we can do so with ball and cylinder, overlapping spheres, and so on. Let's do overlapping spheres. That's the structure, and that's the electron density.